Okay, you can start class now. Okay. Guys, good morning.
Yes, sir. Yes, sir.
Good
Good morning,
morning,
sir.
sir.
Good morning. Now we can start class now. Okay. Here. Today we can see about concrete mix design. Okay, this is unit 2. Concrete mix design, mix design. So today we can see about some introduction regarding concrete mix design. Okay. And next class we can go for directly for the problems. I will give you the design steps and then we can go for problems. Okay. Maximum we try to complete this unit within 3 to 4 hours. Then only we can go for other units. Okay. This is so easier. This won't be like unit 1. It's a huge number of topics. Okay. Whether I am audible?
Yes,
Yes,
sir.
sir.
Audible, sir.
Okay. Okay. So concrete mix design. So first, so we'll go for the introduction. Okay. So introduction. So already in the unit 1, we have discussed about concrete and what are the tests we are going to do for fresh concrete, hardened concrete. Okay. And also the properties of aggregate, cement, everything we have discussed in the first unit. Okay. Now, so we can go for mixed design. In mixed design, okay. So concrete is widely used as a man-made construction material. You already know. Okay. This has been going on as a long process for over a decade. Okay. Of many years, for many decades, it has been going on. So concrete mixed design. It is a process of selecting suitable ingredients of concrete, determining the relative quantity. Yes, determining the quantity, determining the meter cube. We will be telling in meter cube, right? How much volume of concrete you have to put. It will be designated. It will be decided in meter cube. Okay. In the meter cube, how much volume of each and every quantity of material to be added. Okay, this will be determined using relative quantity. So aim of producing concrete is mainly to achieve your objective of producing a fresh concrete is to achieve strength, durability, and workability, right? So, once again, so your objective is producing the concrete, fresh concrete is you have to achieve the strength after curing, after becoming hardened concrete, it has to achieve the strength as per the mixed design and also durability in the long term process and workability. Okay, if these three factors will in that the third factor which will determine the economical activity. Okay, if it is workable, it will be economical first. Okay, it should be economical as possible. Okay, so based on the economy, we have to design the workability. So these three are the primary objective of producing a concrete. Okay, principles of mixed proportion. Principles of mixed proportion. So basic consideration in mixed proportion. So it's a design of concrete mixes involves determination of proportion of the constants. Okay, it's mainly if the concrete mix it's for proportion of the constants, mainly for determining the proportion of the constants which are being added in the concrete wall, concrete matrix. What are the materials? So cement, all you know, cement, water, coarse aggregate, and fine aggregate. For determining these proportions only, we are going for the mixed design. Okay, we are going for the mixed proportion. Next, the admixtures. Admixtures are added that produce specified properties in fresh and hardened concrete with the maximum of overall economy. Yes. So, in previous slide, we have seen these are the basic components to be found in concrete. Okay, these four are the basic components to be found in concrete. So, next, we are going to discuss about admixture. Admixture is nothing but an additive. Admixture is nothing but an additive. Okay, so admixture is added and to produce a specific property of fresh and hardened concrete. The main purpose is it has to make workable. Okay, there are following parameters which will be arrived using admixture. So as your economical, okay, we are going for huge column, we are going for huge concrete mix. Okay, I already discussed these points already. As we are going for RMC, okay, we are going to shift the fresh concrete mix from one area to another area, so it's going to undergo transportation. Okay, so it's going to undergo traveling. So as the duration increases, so you have to maintain the setting time and you have to maintain the strength. Okay, and you have to maintain the durability. So for maintaining all these factors, okay, we are using admixtures. So admixtures will produce specified properties in fresh and hardened state concrete, maintaining the overall economy. Okay. Economy won't be increased because if you are increasing the cement, okay, if you are making the rich mix, okay, not to make it workable. That is one parameter. Okay. If you are not to increase the binding quality, if you are increasing the admixture, that economically it will be you can reduce. Okay. Using large amount of cement, or for example, reducing some percentage of cement using admixture, you also improve the binding property of the concrete. Okay. As per the design mix for the given mix, this improvement additive or admixture will also improve the binding nature of your concrete. Okay, so these are the one of the factors for using admixture. So there are several factors by which So admixture will improve the desirable properties of a fresh and hardened concrete and also will sustain the economical activity of the concrete. Okay. Next, workability important for concrete in the fresh state. Okay. The compressive strength and durability in the hardened state of concrete. In hardened state of concrete, this admixture will maintain this admixture will maintain the compressive strength also durability in the serviceability criteria. So workability will be maintained during fresh concrete stage. Okay, and basic assumptions are made in design of PCCR. So what are the basic assumptions made while designing a plain cement concrete? The compressive strength is governed by yes. The compressive strength is governed by your water cement ratio. Okay, compulsorily it's maintained only by your water cement ratio. Primary factor is your water cement ratio. Then there are several factors. And for a given aggregate, next point for a given aggregate, the characteristic workability is governed by its water content. Yes, for a given aggregate, the characteristic workability is governed by its water content. Yeah, water content only maintains the workability factor primarily. Okay, okay. Next, medium strength. Okay, they are dividing the concrete mixture into medium strength and high strength. Okay, so in medium strength also, water cement ratio plays a main role in the case of hard and straight concrete. Okay, for achieving the strength. For a given aggregate also, the workability of concrete is governed by water cement ratio, high strength. In the case of high strength, okay, it should be low workable. Okay, considerable interaction occurs between these two criteria. Okay, and validity of some assumptions may be limited. Yes. Okay, there should be a better interaction between the concrete matrix because you are making it as low workable. So you are reducing the workability. Then also it should maintain the good interaction between the concrete matrix. So all the components should have good interaction in the matrix. Okay. So for that only we are going for the several other activities. Okay. That mixtures are some are superplastics. So other factors affect the properties of concrete. Other factors affecting the properties of concrete are quality and quantity of cement. First, quality and properties of concrete is maintained mainly by your quality and the quantity of cement. Okay, if you are going for so this quantity is more, you are going for rich mix. Quantity is more, you are going for rich mix. Okay, so this will improve the grade of concrete. Quantity is more, you'll go for rich mix and you'll improve the grade of concrete. Okay, and also quality. Okay, if the quality is not there, so if you are designing for example, if you are designing for M30 grade concrete, if the quality of cement is not that much to that grade, okay, if ultimately what happens, so you won't achieve the strength after the hardening of concrete, you won't achieve the 30 Newton per mm square. So if it is running M38 concrete after 28 days of curing, you will achieve 95% of strength, right? You will achieve 95% of strength. After 28 days of curing, you will achieve 95% of strength. Okay. For example, 30 means at least you have to achieve 28 Newton per mm square. But you won't achieve 28 Newton per mm square because the quality of cement is not that much good. You won't achieve the exact grade of concrete. Okay. Next, water and aggregate. Water and aggregate, and procedures of batching, mixing, placing, and compaction, curing, etc. So yes, the quality and quantity of cement. So these are the factors affecting the properties of concrete. The first one is your quality and quantity of cement. Next, your usage of water and aggregate. Okay, and also the procedure of your activity from preparing fresh concrete, batching, mixing, placing, and compaction, curing. So these factors are not achieved properly. It will also affect the properties of the concrete. Okay. So these are all the following patterns: batching, mixing, placing, compaction, curing. If any one of the activity is not maintained exactly, you will have a problem. Properties of concrete related to the mixed design. So concrete has a satisfactory property in both in fresh and hardened state. Okay. So a satisfactory property in both in fresh and hardened state. Workability is a desirable property of fresh concrete. Strength and durability. So workability is desirable property of fresh concrete and strength and durability. Okay. So this is a main achievement for maintaining the strength and durability. Demand satisfactory properties of concrete in fresh. Same point will be repeating. Demand satisfactory properties of concrete in fresh and hardened state may bring requirement in material and mixed proportion. This satisfactory property is achieved. This satisfactory property of both fresh and oral state will be achieved only by the material and mixed proportion. Only by the material and mixed proportion. The physical properties of your mixed design. Cement, fine aggregate, coarse aggregate, these are the and water are the parameters that are used mainly already or no. Cement. The most important constituent is a binding medium for discrete ingredients. So all are discrete ingredients used in concrete, right? So this is going to be a binding medium for all these discrete ingredients. A naturally occurring raw material. This is a naturally occurring raw material, sometimes blended with industrial waste. Yes. Now we are using industrial waste, right? Maximum of industrial waste. We are, now we are using a maximum of industrial waste. Cement comes in various types and chemical composition. Cement comes in various types and chemical composition. Right now there are several types of cement are using. Okay. Each there are only two types of cement. One is OPC and one is PPC. OPC is nothing but ordinary Portland cement. PPC is Portland Pozzolanic cement. There are two cements used in the olden days. Now there are several types of cement which are used based upon the nature of work, based on the nature of structure. It depends upon the type of structure, okay, nature of work. Cements are varying scale, high expertise cement, high strength cement, waterproofing cement. So there are several cements that are used now, okay. So depend upon the workability factors and all the several factors, we are improving the properties of cement as per the work which are going to undergo, as per the structure which are going to design. Okay, this regarding cement we'll discuss once again at the end of this in this unit. Okay, aggregate. Aggregate occupies 70 to 75% of the volume of concrete. So cement and water is going to be 25%. Okay, remaining this fine aggregate and coarse aggregate is going to occupy 70 to 75% of volume of your concrete. So these aggregates are going to act as an inert material. Okay, inert material. So it won't react to other materials. Maximum they are just as per the research work. They are confirmed that there won't be any chemical interaction of aggregates with the other components. Okay, that is a major parameter of your aggregator. So your aggregate is a majorly a influence of your property. Aggregate is going to be the major parameter for discussing this thing. Once again, so and we can start now. So aggregate going to occupy the 3/4 volume of your concrete. Okay, it's going to occupy the 3/4 volume of your concrete. So it won't be chemically it won't react chemical. There won't be any chemical reaction. It is inert. Okay, the fine aggregate won't react with coarse aggregate. Of course, aggregate won't react with your cement or the or with water, so there won't be any chemical reaction between these components. Okay, but nowadays we are adding some chemical compositions like other things like these are having some chemical interaction that we can see in the future cases. So primarily there won't be any maximum of chemical interaction. As we are using now the several admixtures and several uh, other components in other industrial wastes in your cement preparation, there are some chemical interactions now it has been found. Okay, but but it won't have that much impact on your strength parameters. For that, also they are having some catalyst for reducing the effect. They're using some catalyst in the concrete. Okay, so it won't have that much maximum impact on the fresh concrete or hardened concrete. Next, well influenced by physical properties of aggregate, yes, substantially influence the properties and performance of concrete. Yes, these components substantially improves the properties and performance of concrete. Okay, water for mixing and curing which are using. So it's basically so it should it's a main primary characteristic. It's used for mixing and curing, and clean and free from injurious amount of oils. Okay, it should be free from. It should be clean first, and it should be free from other salts like oil, acid, alkalis, salts. So then only you don't have any chemical interaction. Okay, first, there won't be any interaction. If water content having pH value more than 7 also, it will have more alkali content. If it is having below 7, yet if it's going around below 6 or 5, it will have more acid content. Okay, getting more pH content above 9 will have more alkali content. So it should be moderately between 6.5 to 8. Then only it's called a good water. Then only it will be called as potable water, and it can be used better. It can be used easily for concrete preparation. Okay, that will be good for concrete preparation. Okay, maybe deleterious to concrete and steel. Yes, if you are having more alkali content, okay, it will be deleterious to concrete or steel. So steel, if you are having more alkali content, automatically it will undergo corrosion activity. It will initiate the corrosion activity. It won't go for corrosion. It will initiate the corrosion activity. So types of mixers. So types of mixers. So mixed proportion can be so mainly mixed proportion can be selected to ensure the workability of fresh concrete. The major important point is in a mixed proportion can be selected to ensure only mainly for maintaining the workability of fresh concrete first. Next, once it is hardened, it should gain the required strength, durability, and surface finish. The second point, once it gets hardened, it should gain this strength, durability, and surface finish. And the proportion of the cement, aggregate, and water required strength are fixed. So the proportion of these things should be fixed. Okay, it should not vary. So first we can there are two mixes majorly will go for one is nominal, another one is design mix. There is another mix called standard mix. Okay, totally three. Two is main. Okay? Nominal. So nominal mixes fast specification of concrete, prescribed proportion of cement, fine aggregate, and coarse aggregate. So as per the codal provision, for example, IS 456, for M10, M15, M20, M25, and all, we would have given the mixed proportion for cement, fine aggregate, and coarse aggregate, right? So with that mixed proportion, whatever the material, with this mixed proportion, we are going to design, we are going for the concrete mix, okay? But the properties of this cement, fine aggregate, coarse aggregate will vary. They would have designed for cold provision before. Yeah. So they are designed in a cold provision. They are designed okay, but they would have designed for some other. They are designed for the material for some with some variation in the property. But if you're going for a site, okay. If you're designing a concrete mix, so we are selecting this. So we are sorry so we are collecting the materials like fine aggregate, coarse aggregate, and cement. Okay, from the plants. If you are using the same design mix, if you are using the same mix proportion and preparing the concrete, okay, whether it will achieve the same strength. For example, if you are designing M20 grade concrete, okay, we are collecting the materials, all the ingredients, and we are mixing, and we are preparing the concrete, fresh concrete. Okay, after hardening, okay, if you test the concrete, okay, if it is M20, it is not it is not sure that it should attain M20 grade concrete strength. For example, M20 grade concrete strength after 28 days is 95 already percentage already told. That means it should achieve strength around 80 Newton per mm square, 18 19 Newton per mm square. Definitely, it won't achieve maximum 90%. It won't achieve 18 to 19, 18 to 19 Newton per mm square. Okay, why it is not achieving the value means because the properties of fine aggregate, coarse aggregate, and cement will vary from site to site. Okay, mainly this fine aggregate and coarse aggregate. So each and every site, these properties of the material will vary. Specific gravity will be varying. Okay, so and your fineness value of aggregate will also vary. So all the properties will vary. For example, a setting time of your cement will vary. Consistency value can vary. Okay, so these properties will vary sure. These properties will vary sure. So that is a major drawback for going for nominal mix. Okay, nominal mix, it can be preferable for a minimum floor residential building. It can be preferable for a minimum floor residential building like G plus 1 or G plus 2. It is not acceptable for high rise structure. It is not acceptable for high rise structure. That's why. Ah, okay, it is not acceptable for higher structure because that's why if you see in the codal provisions, they would have given this nominal mix value for till M25 only. They would have not specified for higher structure. If higher, sorry, they would not specified for high strength concrete. For example, M30 or M35 or M40, they would not specify that value because it won't be acceptable if you go for a nominal mix because while deciding the high strength, it is not for high strength, it's for medium strength also. If you are designing a concrete mix, it should be designed based on the actual property of the aggregates started from the site. It should be designed based on the actual properties of the aggregate, like fine or coarse aggregate, collected from the site. Okay, so site to site, these properties will vary. Okay, so that's why nominal concrete can be used only in the case of domestic constructions, minimum of G plus 2. Okay, for high rise, they won't prefer nominal mix. Okay, so it offers simplicity under nominal circumstances. It will offer simplicity under normal circumstances. Okay, next. The margin of strength will be specified. The margin of strength will be specified. Okay, it's already strength is specified. Variability in mixed ingredients. Variability in mixed ingredients. The normal congruity for a given workability varies widely in strength. That's the point which you are discussed now. Okay, so the properties of the materials ingredients will vary from site to site, so automatically it won't achieve the record strength which you have preferred. So it will not achieve the record strength which you have preferred, which you have preferred. Okay, that is a major drawback for nominal mix, so it won't achieve the same strength. Then how we are going for construction means we are maintaining the factor of safety, right? We are maintaining factor of safety, so based on factor of safety we are maintaining the quality of the structure. So in the serviceability point of view, we see the quality goes on reducing. Okay, that's why the nominal mix we won't prefer for high rise. Okay, next design mix. So design mix is a thing which you prefer for 90% of your construction. Okay, so performance of characteristics specified by the designer. So designer will specify the mix proportion. So based upon the site condition of the aggregates, okay, the properties of aggregates will be checked and they will go for design calculation. So from the design calculation, they will say the density of the materials. From that, the total volume, how much you are going to per meter cube volume of concrete mix, we will arrive the quantity of materials required for per meter cube. For example, per meter cube quantity of concrete. From that, we will arrive the mix proportion ratio. So this will be exactly designed as per the property of concrete. So if you are preparing the concrete mix as per this mix proportion, designed mix proportion, you will achieve the exact strength if exact strength as it is preferred. Okay, if you are design, if the design mix is given for M30, mean you can achieve the 95 percentage of M30. Okay, you can achieve the 95% of M30. And another important thing, and you have to you should maintain the proper activity during the following factors which you have discussed earlier. What are the following factors? During during this batching, mixing and placing and compaction and curing, we have to maintain the exact procedure. Okay, there should not be any variation in the procedure. If you are maintaining the exact procedure and if you are going for the exact design mix, you will achieve the exact quality, exact strength of concrete as preferred. Okay, and as per durability factors also, it will give a good maintenance. Okay, and durability factors also it will achieve. Okay, the serviceability point of view also, you will achieve the you will achieve good life. Okay, in serviceability point of also, we can achieve the good life. That's it. Okay. So with this, we can wind up this unit. Okay. With this, we can wind up this introduction. And next class, we can go for the design mixer. First, we can see the design procedure. Okay, I'll explain the design procedure. Okay, you have to discuss once again. Okay, if you don't have any doubts, we can go for the design problem. Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Share your attendance.
Okay, sir.